Hello everyone. So today again we'll discuss one question from CAT 2020 slot 2. The set is, or the question is moreover related to integral solution. That's an algebraical part. It's one of the important topics because you will find a lot of questions related to integral solution, whether it's an algebra based question or else LRDI. Definitely you'll be using integral solution format in CAT examination. So let's directly move to the question here. So the condition given, the number of pairs of integers xy satisfying x is greater than or equal to y, y is greater than or equal to minus 20, and 2x plus 5y is equal to 99. So integral solution represents that I should have the integral value of x and y. So just to identify this, I'll plot a diagram here. So I'll plot the equation 2x plus 5y is equal to 99. If we'll plot an equation 2x plus 5y is equal to 99, it will be something like this, right? So it's basically 2x plus 5y is equal to 99. And my conditions given are x should be greater than or equal to y, and that should be greater than or equal to minus 20, right? So my condition is x can at most be equal to y. Also in other sense, suppose if we'll plot a square here, in this case my value should be lesser than this, right? Also I can say if it's a square here, the condition will be x is equal to y, right? So I want to concentrate on the values on this side, and definitely I want to concentrate on the values towards this side, right? So my basic analysis is, if we consider, my basic analysis is I have to find out all the integral values at this point, right? So that is my basic analysis in this case, right? But how do you solve the integral solution questions? There will be a few set of movements which you need to keep in mind here. Obviously I want the value of y to be lesser than x in this case. So let's consider this case where both the values x and y are positive. So let's concentrate on this part for the time being. So both x and y should be positive here. Now suppose I'll put y as 1 here. If I'll put y as 1 here, I can definitely find out the value of x is supposed to be nothing but 47, right? Now the next is, that's the important part which you need to keep in mind here. Whenever you're dealing with the integral solution part, the next value of x and y, since x is a larger value available here, I have to reduce the value, and for y I have to increase the value. That represent whatever is the coefficient of x, I should add that one to this part, and the value of the coefficient of y should be subtracted from this figure. That will be the next movement in these cases. Why, we'll discuss about that later when we'll cover the integral solution formats, right? So now suppose I'm adding 2 to this value, that means this figure is supposed to be 3, and I'll subtract 5 from this figure. The figure is supposed to be nothing but 42. So you can check 42 and 3 are the next two numbers which will definitely satisfy the condition. So I'll repeat the same thing here. So next will be nothing but, I can take this value as 5, and this value will be nothing but 37, right? Next value is nothing but this one will be 7, and this value is 32, 9, 27, 11, 22, and then I'll have 13, and this is 17. Further I cannot take the value because after that the value of y will be greater than x. Now I can identify, I have 1, 2, 3, 4, 5, 6, 7. 7 values are there which will satisfy the condition. Moreover, the important part here was to identify that I am following an arithmetic progression, because I have a common difference here, right? So I have a common difference in this case, right? Now, so I'll just mark this was the point, right? So or else I can identify the value of x here is nothing but 47 and the value of y is nothing but 1, and y, if we'll take the movement of y, I'll have a common difference of 2 here. That means this part, the value of y is supposed to be minus 1 because I want a common difference as 2. Then the next figure which will satisfy the condition is minus 3, minus 5, and this process continues here till the last figure here is supposed to be minus 19, as it's an odd number and the value of y should be greater than or equal to minus 20. Now you can identify that this is following an arithmetic progression here. So I can say minus 19, which is my last term, should be equal to minus 1 plus n minus 1, where n is the number of terms available, with a common difference. Common difference is minus 2 in this case, right? Also because minus 18 by minus 2 is supposed to be n minus 1, right? So n minus 1 is 9, n value has to be nothing but 10. So I have 10 figures available here, I have 7 figures available here. Total number of figures should be 10 plus 7, or else 17 values will be there which will satisfy the integral values of x and y for this particular situation. That's all for today. Thanks for joining us.